Hello everyone, welcome to the second module, which is Python for data science. So we are going to start off with this module. We've just completed the first module where we looked at the basic introduction about Python, and we also looked at different concepts in Python. So the agenda for this particular module is we're going to cover n number of different topics. The first topic that we're going to be looking at is called package manager and installation. The second topic is NumPy introduction. The third topic is accessing NumPy entries. Fourth topic is Pandas introduction, Pandas series and DataFrame. The last second topic is Pandas function, and the very last topic is Pandas saving and loading frames. So everyone here, we are basically going to cover two very important Python libraries that are going to be helpful both in data science as well as data analytics. So the very first topic, let's discuss what is a package manager. Okay, so a package manager is a tool that simplifies the process of installation, updating, and even managing your software packages on a computer. So this involves handling your entire life cycle of the software packages, like from installation to updates and even removal of your software package, software packages. Now, the software packages, what they do is that they will automate tasks such as, resolving dependencies. They will ensure that you have a version consistency, and it will also facilitate the distribution of software. Now, why is there a need to use these package managers is because it is going to efficiently handle your dependencies, ensure that there is software version consistency, and also going to facilitate your software distribution. Now, when I say that it is going to, handle software dependencies, or it is going to handle or automatically manage dependencies, what I mean is that the package manager automatically manages your dependencies, ensuring that all the required software components are installed and even compatible with each other. Also, these package managers, they will maintain, a record of installed packages and their versions, which are going to prevent conflicts and even ensure that there is consistency in your software environment. And lastly, package managers, they provide a very centralized and an organized way to distribute, share, and even install these software. So it is going to contribute to a more streamlined development and the development process. Now, there are two very popular package managers. Okay, now we know what a package manager is. So the first one is pip and the second one is conda. So pip stands for, it's an abbreviation. So pip stands for Python package index. Okay, so pip is the default package manager for Python. Whenever you're working with Python and whenever you want to install any library that is not a standard library in Python, you always use pip. You say pip install and let's say Flask, or pip install NumPy, etc. So you're going to use pip, which is a default package manager for Python, and it is like the go-to tool to install as well as manage multiple different Python packages. Also, pip is specifically designed for managing Python packages, handling the installation, and even the management of dependencies efficiently. Whereas Conda Conda is a very versatile tool, that serves as both as a package manager as well as an environment manager. Okay, it is just not limited to Python. It can also manage packages from various different programming languages. So Conda here, it goes beyond Python, okay, unlike pip, and it is going to support packages from different languages, making it very suitable for a wide range of projects. So it is particularly, popular in, data science as well as scientific computing, computing due to its very robust environment management capabilities. Now, you might be wondering, how can I create these, environments? So let me just show you. Okay, I'm just gonna share my screen. I hope my screen is visible. So this is our Anaconda Navigator. So previously in our previous module, we learned how we could install it, right? And then after we have installed it, this is our home page where there are multiple different IDEs that are available. IDEs basically mean integrated development environments where you can write down code. So here you also have another tab which is called as environment. So you can create your own environments and add multiple different libraries, packages into it, and you can work on it. Now, what we have done is I have just created here an environment which is called as my env. But here what I'm going to do is I'm just going to show you how you can create an environment and how you can also activate your environment and install multiple different packages. So let's say, for example, let me just so what you need to do is to create this environment. Let's say you want to create a Conda environment, okay? So it is going to include setting up like a separate environment. So in your Python interpreter and even installing these packages, right? So the first thing that you do is you have to open your terminal or you can open the command prompt. So I'm just going to open. What I'm going to do is I'm going to just open my command prompt. Let me just navigate. I'm gonna just go to Anaconda, and under Anaconda, I'm just going to click on Anaconda prompt. It has loaded, everyone. Yes, so this is how it's going to look like. In the Anaconda prompt, what we have to do is we are going to activate our virtual environment. So right now here I have created one, okay? So, but in your cases, you all wouldn't have created. So all you all have is base root. So what we're going to do, whenever you want to create a new Conda environment, you just need to write Conda space create space two hyphens, and then you give a name and then give a space, and here you're going to give the name of your environment. So my environment name would be project 1. Okay, just a pseudo name. You all can choose whatever name you all want, and also I can mention the Python version I want to work with. So I am going to say Python 3.9. All right, and then after that I'm just going to click enter. Now, after this step, what is going to happen when you're going to run this command, a new Conda environment is going to be created. So this command creates a new Conda environment named, which is project 1. Okay, as I mentioned here. So the name is going to be project 1. And also here, it's going to just ask me if it can proceed. So always click on Y and select enter again. Now, everyone, the name, the hyphen name here, it stands for, it specifies the name of the environment, and Python equals specifies the Python version that has to be installed in your environment. Okay, so after this, whenever you're going to give this particular command, the next thing that's going to happen, it's going to ask you if it can proceed with the installation. Like the Conda will display a list of packages that that it is going to install, and it is going to ask you for confirmation. That's the reason why I typed Y. Okay, you need to enter you need to enter Y to proceed with the installation. Now, not only we are creating this particular environment, next what we need to do is we need to activate this. You can see to activate this environment, use Conda activate project 1. This is the name of my environment. So I'm going to type Conda activate project 1 and select enter. Now you can see that here we have activated the environment. Okay, the prompt to indicate, you can see that here we will have the name of our environment. Okay, before the directory that we're going to be working with, and also in the background you can see the Anaconda Navigator. Another environment has been created here, right? So I'm just going to click on it. Just taking some time to load. So until then. Yes, so you can see here, these are all the basic, packages that have been installed. All right. Another thing that you can do is whenever you want to deactivate this particular environment and you do not want to work in this particular environment, you can just write Conda deactivate. Okay, and that's how. And another thing is that this particular environment, inside this particular environment, you can see we have the pip manager, we have Python, we have SQLite, etc. So now what I'm going to do is I am going to install. Okay, so let's say you want to install a package within the Conda environment. You can use Conda install and you can give the package name. All right. So here what I'm going to do is I'm going to say Conda install Flask. Okay, Flask is another, Flask is another standard library which helps you create web applications easily. So here I'm just going to click on Y. So you can see these are the multiple different packages that will be installed in my environment, which is project 1, when I'm going to give the command conda install, a package name. So our package name here is Flask. So I'm going to say Y and select enter. And it's going to download and extract all of these different packages. So everyone, as you can see here, okay, here everyone, it's just going to take some time to reflect it in our environment. So this is how you can install multiple, firstly, this is how you can create an environment and also how you can install multiple different packages. All right. Now going further, okay, navigating to project 1, you can see here the Flask framework, okay, has been downloaded here. This is one type of framework just like Django, okay, and along with that, we have Jinga, so other different packages that are required whenever we are using the Flask framework. Now, next up, now that we know how to create an environment and how Conda is not only responsible for installation, dependencies, and removal of packages, it can also help you, maintain environments. Let's move ahead to our next important topic, which is installing required libraries. So here we're going to be focusing on NumPys and Pandas. Okay, NumPys and Pandas are like two powerful libraries in the Python ecosystem. Okay, they're widely used for numerical computation, data manipulation, and even analysis. So NumPy, okay, which is our first, library here, it serves like a foundation for numerical computations in Python. So it provides, support for multi-dimensional arrays and even matrices, along with a collection of mathematical functions so that it can operate on these arrays efficiently. So there are key features like multi-dimensional array, meaning that NumPy introduces the NumPy.nd array object, which allows the representation of a multi-dimensional array. And NumPy also, it also includes a wide range of mathematical functions, right? So these mathematical functions can operate element-wise on arrays, facilitate complex numerical computation on your arrays. Also, NumPy implements to optimize for arrays operation, making it very faster than the traditional Python list for numerical, computations. We also, so if you want to install NumPy, you can go ahead and in your terminal you can type pip install NumPy, or in your or also in your terminal you can just type conda install NumPy. It is going to help you install this library. Next up, we have Pandas. So Pandas, is also another very powerful library for data manipulation as well as analysis in Python. It introduces two primary data structures. The first data structure is called a series, which is a one-dimensional labeled array, and there is also two-dimensional label array, which is called as data frame, series and data frame. Okay, so like the key features of Pandas is data cleansing. So what does data cleansing mean? So Pandas specify, it basically, it actually simplifies the process of cleaning and transforming data through its flexible and also its very intuitive API. Also, the operations align on both row and column labels, making it very easy to work, okay, with heterogeneous and labeled data using data alignment. Also, it has a very effective, data indexing and selection for data analysis and manipulation. And also it has specified tools for working with time series data, essentially for, tasks like, financial analysis. So Pandas provides tools for handling missing data, making data analysis more robust. Now, all of these key features might come across new for you all, but when we are going to be looking at a few hands-on, we will understand this better. Okay. Now, how do you install this using pip command or conda installation? Okay, conda install pandas. Now, a few advantages of both of these libraries are that both NumPy as well as pandas, they simplify very complex data analysis tasks. They will provide you with a high level, abstractions and functions that will reduce the amount of boilerplate code. These, libraries, they also play a very crucial role in data visualization by providing the underlying structures and even the functions that, that are necessary for creating meaningful plots as well as charts. Also, NumPy is like a foundation for numerical operations. So a key requirement for machine learning algorithms is NumPy and Pandas. Okay, and also Pandas, on the other hand, it actually facilitates data manipulation and pre-processing, which is a critical step in the machine learning pipeline. So by installing and leveraging these libraries, you as a, you as actually a user can streamline their data analysis workflow, provide more effective visualization, and even empower advanced statistical and machine learning analysis. Now, moving ahead, um, we're going to discuss about both NumPy as well as pandas. So firstly, everyone, let's look at and understand NumPy in detail. We're going to work with a few arrays, and even we're going to perform a few basic array operations. Now, NumPy, everyone, as I already mentioned, it's like the foundational library for numerical computation. Okay, it provides like a support for large multi-dimensional arrays and even matrices. So, along with an extensive collection of high-level mathematical function to operate, it can also provide you a support for extensive high-level mathematics. Now, let's understand these. So there are key features like multi-dimensional array, mathematical function, and broadcasting. Okay, so this is nothing but mathematical. It can perform advanced mathematical operations, like it provides including basic arithmetic operation, trigonometrical functions, exponentiation function, logarithmic functions, and so on. So these libraries, they operate like element-wise on arrays, and they also enhance their, utility for complex, numerical computations. And the NumPy, they have these structures, okay, that are efficient for storing and even enabling numerical operations faster. So lastly, broadcasting means that the broadcasting is like a very powerful feature of NumPy that allows for implicit element-wise operations on your array of different shapes and sizes. Now, working, arrays in NumPy. So arrays in NumPy, you can create arrays, okay, using numpy.array and other constructors. So we will see that. Okay, so firstly, not only you can create them, okay, you can create them using a constructor which is called as numpy.array. You can also use other constructors like numpy.zeros, numpy.1, numpy.arrange, etc. You can also, the size of the array and is actually the dimension of it. So you can specify the total number of elements inside it. And also what you can do is NumPy helps you to effectively index and slice your arrays. And lastly, NumPy arrays have a specified data type. So it is important to understand and understand these data types and use them effectively so that you can even save the memory. Okay, you can use memory efficiently. It has common, operations like element-wise operations. So NumPy will support element-wise operations on array, allowing you to perform arithmetic, trigonometry, logical operations, efficiently without needing to explicitly loop them. You can have aggregation functions like sum, mean, min, and max. You can implicit expansion of array for compatible operations. Now, on array manipulation, so here it says reshaping, combining, transposing, etc. So NumPy allows to change the shape of the array without changing its data. So it's basically enabling flexible manipulation and even preparation of data, for various different operations. Also, NumPy provides functions to concatenate and even split these arrays. So concatenation means joining, okay? And it also allows you to combine or even extract specific portions of the data efficiently. And lastly, it helps you swap the access of array. And NumPy will provide this using a function which is called as numpy.transpose. Okay, this is very useful for data manipulation and linear algebra operation. Now, here, everyone, these are a few basic, operations that we will be looking at. So these are all codes that are given here that we are going to be looking at. I have a few codes, and this is the output. So what I will do is, firstly, I'm going to share this file. Let me just quickly share my file. So here, everyone, what I will do is I am going to navigate and I'm going to launch my Jupyter notebook, everyone. So here, what you can do is you can just click on install and then you can launch it. All right, I've just clicked on install, and then when you are going to launch it, it's going to launch in one of your web browsers. Let me just share my screen. Yes. So here, everyone, I have downloaded all the files. All of these files will be provided to you all. So here, you can see that we're going to start off with basics. Is NumPy, we're going to import NumPy. So this is also mentioned in the PPT, but I would like to explain it in this IDE. So I'll just wait for everyone to quickly launch this. So everyone, as you can see here, we have provided these files to you already. So let's go through the entire code. Okay, so in the first cell here, what we have done is we have done the most important step, that is importing NumPy. Okay, we are importing the NumPy library and we are going to rename this, which is also called as, we are giving it an alias, okay, which is called as NP. So this NumPy library is a very powerful library, and what by giving this an alias, what we are going to do is we're going to basically refer to NumPy as NP throughout our program. Okay, so after this, what we're going to do is we are going to create NumPy arrays. So now how can you create a NumPy array? It's using dot array function here. Okay, so firstly here we have created two different variables, ARR1 and ARR2, used our assignment operator. Then using our using our library, which is NumPy. I'm going to say NumPy.array, and then what we're going to do is we are going to give a sequence of numbers here. Okay, so NumPy arrays are similar to Python list, but it has added functionalities for numerical operations. So we have added a sequence of numbers from 1 to 5 and 6 to 10 here. Next, after that, what we are going to do is we are going to perform basic arithmetic operations on all of these array 1, ARR1, and ARR2. So the first operation that we're going to perform is addition. The second operation we're going to perform is subtraction. Okay, addition is denoted using the plus symbol, subtraction is denoted using the minus symbol, then multiplication using the asterisk symbol, and division using the forward slash symbol. And exponentiation is represented using two asterisk symbols here. Now, so here everyone, as you can see, these are all different basic array operations. So these operations are going to be applied element wise. Okay, when I say element wise, meaning that each element in the array is combined with a corresponding element in the other. Like for example, here when I say ARR1 plus ARR2, here the element 1 is going to be added with 6. The element 2 is going to be added with 7. So with the corresponding element, okay, it is going to be added or subtracted or multiplied or divided. Now here, when we have given a few print statements, okay, so in Python all you have to do is give print, and whatever after you give the print statement, you have to give these parentheses, and inside this parentheses, whatever is inside these double quotes will be printed as it is. Comma helps you to combine strings as well as different variables. So the variable is ARR1, which is array 1. So initially we're going to just display both of these arrays, okay, array 1 and array 2. Next, after that, what we are going to do is we are going to find the sum, okay, addition of these two arrays. So the addition of these two arrays is 7, 9, 11, 13, and 15 is going to be added to the corresponding element. Okay, this is the difference, this is the product, this is the division output, and this is the squared output, meaning that all the elements in ARR1 here, okay, which is 1, 2, 3, 4, and 5 are squared to the power of 2. Okay, everything to the power of 2. So 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, 16 to the power of 4 to the power of 2, and 5 to the power of 2. So this is going to be the result. So everyone, this is the basic, introduction to NumPy. Next up, what we're going to do is we're going to look at a few more important functions of NumPy. So I'm just going to, so this is our first file here. I hope everyone's clear with this. The next one that we're going to be looking at is, yes, it is basic array functions. Now, everyone here, about basic array functions, okay, what we're going to do is we have, again, what we have done here is we have created, okay, we have actually imported NumPy, created two different arrays, okay. After creating both of these arrays, what we're going to do is we are going to find its mean, median, STD, sum, min, and max. Okay, so once we are going to complete all of these functions, okay, we will come back to these files. So let me just give you an introduction first here. So yes, this is our first output. Okay. Now going to our second output. All right. I think we can actually complete that and come back. Yes. So here that we have completed this, I'm just going to close this file and navigate to this second file here. Okay, so this is also the same input that we have taken here. Okay, here what we are going to do is we have taken two different arrays. If you want, you can change the input, but I'm just going to keep them the same. ARR1, which is our first variable, and this is our second variable here. And the first basic operation that we are going to apply is called as mean. Okay, So here what we are going to do is we are going to use the mean function and pass our first array, which is 1, 2, 3, 4, and 5. So when mean basically means average. Okay. So you're going to add all of these numbers and divide it by the number of elements. So which is 5. So here 5 plus 4 is 9. So this is going to be 5. So it'll be 15 divided by 5. So 15 divided by 5, the output is going to be 3. So you can see that the output here for mean is 3. Next up, we have median. Median basically is going to give you the middle value of your array. So the middle value of array is 3. So you can see the output is 3. Then we are going to find the standard deviation, which is the measure of the data spread. Okay, so when we're going to measure the data spread, the output is going to be 1.14. Next, what you can do is you can add all the elements inside your array. So when you're going to add all of these elements, the sum is going to be 15. Then when you're going to find the max element and the min element, basically the element, you know, in the so here we're going to just compare these elements. So the max element here is 5 and the min element here is 1. So max element output is 5 and min element is 1. So these are also a few basic functions using NumPy. Next up, we are going to be looking at, yes, we're going to be looking at a few functions. Okay, so what I'm going to do is I'm going to simultaneously explain, okay, these functions, and then we're going to look at the code too. Yes, let me just start off with some of the very important functions of NumPy. Yes, I'm just going to wait for everyone to navigate back. Yes, so everyone, the first NumPy function that we are going to be looking at is called as square root function. Okay, so the square root function helps you to calculate the positive square root of each element in the array. Now, the syntax of it is going to be numpy.sqrt, and then you're going to pass the array inside it. So let's look at the code for square root function, which is, yes. So firstly, do not forget to import NumPy. Okay, and here we're going to refer to NumPy as NP. If you do not want to do that, you can just keep it as NumPy and use all the different functions. Then we're going to create an array. Okay, this array here has elements, a sequence of elements 4, 9, 16, 25, and 36. Now, after that, what we are going to do is we are going to use our square root function. So our square root function here, okay, you can see that how you can use it is I have created another variable which is called a square root result, which is going to hold the square root result. Then I'm going to use my function sqrt and then pass my array inside it, which is arr. Then I am going to print the result here, okay, using the print statement. So you can see that the square root of 4 is 2, 9 is 3, 16 is 4, for 25 is 5, and 36 is 6. So this is our output. Okay. Next up, so everyone please remember that this is the function .sqrt. Next up, we have exponentiation function. Okay, so the exponentiation function, what it does, it actually raises the mathematical, constant e to the power of each element inside your array. So you're going to provide an array, right? So that array is going to be raised. So each element is going to have a constant e. Okay, so e will be raised to the power of the element that is going to be passed inside your array. So the output will represent the result of this calculation. So here we are calculating the exponentiation of each element in the array, and the function name is exp. Now let's look at the code for this. Yes. So here you can see that we have the exponentiation function. So again, we have created another variable here, and this particular variable is going to store the result of exp. And then here we are going to also pass our array, which is 4, 9, 16, 25, and 36. Now after that, I'm going to print my output using this print statement. Now, if you're going to look at this output, okay, firstly, let me tell you how this is working. So let me just copy this array. I'm just going to add it as a comment. Okay, so this is our array here. Now, how the calculation will be done is that we are going to use this mathematical, constant, which is e. Okay, so e is nothing but e is approximately equal to 2.17, I think, no, 7171828. Okay, approximately. This is what e is. Equal to. Now, when you are going to calculate, okay, how this particular function is going to operate, np.exp, is that it is going to have e to the power of, okay, e to the power of 4, e to the power of 4, which is the first element. And again, it is going to, yeah, so this is going to be a first element where, the output will be approximately somewhere around 5.49 something, right? So 5.49 plus 0, 1. Okay, so this is going to be your first output, which is approximately equal to 54.598. And again, the second output is going to be e to the power of 9. And then again, the third element is going to be e to the power of 16, and so on. This is how this output is, calculated. So e to the power of 9, e to the power of 16, e to the power of 25, e to the power of 36. All right. So the output represents the exponential values for each element in the original array. So the numbers are expressed in the scientific, notations. You can see here, all of these are represented in scientific notations, where you can see here we have 5.45 etc. e plus 0, 1, which is actually equivalent to, this is actually equivalent to 54.5981, okay, and so on. So basically here, this output that you see, it actually shows the exponential growth of the original numbers when they are raised to the power, when they are raised to the power of e. All right. So everyone, I hope all of you all have got similar outputs here. Next up, we have another function, which is called as the log function. So the log function is represented using numpy.log, okay, in Python, and and here you can see this is provided by NumPy library. So what it does, it helps you calculate the natural, logarithm of each element in a given array. So natural logarithm to the base e. So what is E again? 2.7128. Now let's look at a code for this, okay, to understand this much better. So here, as you can see, we have the log function, okay. So in this log function, you are going to use the function dot log, and then you're going to pass the array. Again, our array is the same, which is 4, 9, 16, 25, and 36. So this is our input. Okay, this is our input here, 4, 9, 16, 25, and 36. And then here we're going to use our log function. So when we're going to use our log function, the natural logarithm is being calculated. Now, what is the natural logarithm? It's basically logarithm to the base e. right? Now here you can see that the output is going to be somewhat like np log 4, then np log 9, then np log 16, np log 25, np log 36, etc. Like for example, it's going to be like this. Okay, np dot log, and the first element will be 4, right? And then we have np log 9, etc. Now, this output is going to be approximately, so the first output is going to be, 1.36, etc. The second output is going to be 2.19, third output 2.77, etc. So the output here, this is going to be your output array. Okay, and each element in the output array represents the natural logarithm of the corresponding element your from your input array, right? Next up, we have the arrange function. Okay, so I'm just not going to navigate back to the PPT. I'm just going to show it to you all here itself. So the array function returns an array with evenly spread values over a specified interval. Now, you might wonder what is the, syntax of this. So the syntax is you give np dot, which is numpy dot, and then arrange, which is the name of the function. Then you give the start index, then you give the stop index, and then you give the step. Now, here you can see that I have given a range from 0 to 10, and then I have given the step as 2. Now, when we're going to print the result that is being stored inside the variable arrange underscore result, you can see that the output is going to be 2, 8, 4, 6, 6, and 8 here. So, everyone, this numpy.array function has generated an array, okay, with values that are going to start at 0 because that is our start index, and then it is going to increment with the step value. So increment value here is 2, and then it is going to stop before reaching 10. It's never going to print the last index number. Okay, before reaching 10, it's going to stop. So the output is going to be 2, 8, 4, 6, and 8. It's very similar to the range function, if you all remember. Okay, and this is this output that you see here, this array output. It represents the evenly spreaded values within the specified interval, which is 0 to 10. Next up, we have another important function, which is called as line space. Okay, so np.linespace function in NumPy is used to generate an array with evenly spaced values over a specified number of samples. So the parameters here, okay, whenever you want to use line space, is that you give np, so I'll just add a comment here, np dot line space, and then you give the start point, comma, stop point, and then what you do is you give the number of samples you want to generate, number of samples. All right, number of samples you want to generate. So here you can see that I have given the start point as 0, the stop point as 1, okay? And then I want totally 5 samples to be generated. So here, the start sequence, it starts at 0, okay? And it stops at 1. And if you count, there are exactly 5 samples, 1, 2, 3, 4, and 5. Okay, so this is how you can use line space function. So this line space function, whenever you want to generate an array with even spaced values between 0 and 1, okay, you can use this. And another thing is, here we have already specified the values. If you want to change the range, you can change the range. First element is 0.0, then second is 0.25, 0.5, 0.75, and 1. So this is about line space function. Next up, we have, there's an E missing, right? Next up here, we have the next function here, which is called as linear equation solver function. Okay, so this is another interesting function. Most of us would have, actually solved any number of linear equations back in school. Okay, and we will see how easy it is to basically solve these linear equations using Python and NumPy. So the np.linear equation solver function is used to solve a system of linear scalar equations. Okay, it's going to have two parameters. So the first parameter is called as coefficient matrix, and the second parameter is called as dependent variables. Coefficient matrix will consist the value of x and y, and dependent variables are going to be the values on the right hand side, which are just constants. Okay, now let's say, for example, here, this is our code. Okay, let's understand this. So the system of linear equation, so whenever we're talking about linear equation, let's understand what they consist of. Okay, so every linear equation is going to have two parts. The first part is going to be coefficient matrix. Okay, so coefficient matrix. The next, another one, it's also going to be represented by dependent variables and dependent variables. Now, after this, so we have to give coefficient matrix and dependent variables into an array. Okay, give two different variables. Okay, two different variable names and create two different arrays. Right. So here, the first array here, it has 2, 3, then 5, 6, and it has two different values here, 8 and 15. Now I'll tell you when it is going to be passed, when both of these variables are going to be passed into the linear equation solver function, which is this one here. Okay, what will happen is that this is how it's going to look like. It's going to look like this. Okay, the first equation is going to be 2x plus, if you're not going to give any symbol, it's going to be received as plus 2x plus 3y plus 3y equals 8. And then the second equation, it's going to have 5x plus 6y equals 15. Right? Now, after this, what we're going to do is we are going to, when you are passing both of these equations inside the linear equation solver function, it's going to solve these functions. It's going to solve these equations and it's going to return you the value of both x and y. Okay. Now you can see that our output here is nothing but, one second, everyone. Let me just run these codes. Yeah. Yes, as you can see here, there are output for the linear equation is the first output is -1 and the second output here is 3.33. So the value of x is -1 and the value of y is 3.33, which satisfies both of these equations. All right. Now, next up, we have another function which is called as the unique function. Now, what is a unique function? So, unique function in NumPy is used to find the unique elements of an array and return them in a sorted manner. It's not going to return you duplicated values. All right. So, here you can see it's identified. So this is these are the sequence of numbers that we have passed. Okay, so the input here contains duplicates for 2 and 3. Okay, and the output here is 1, 2, 3, 4, 5. Okay, it is an array that contains only unique elements and they are sorted in an ascending order. You can see that they are sorted. So unique elements are extracted, and if there are any duplicate elements, they're going to be removed. Therefore, the output is going to represent the unique values present in the original array. Next up, we have another function, which is called as random function. So what is random function here? So the random function in NumPy is used to generate an array of random numbers that are sampled from a uniform distribution over a half open interval. So the half open interval, okay, it can be 0 to 1. and it creates an array of specified shape, and each of these elements in the array is a random value, okay, between 0 and 1. Now, let's say, for example, the shape of the array. So here you're going to give something called as the shape of the array. So this indicates, so whenever I am going to give 3 comma 2 here, I'm going to basically say that this is going to be a two-dimensional array with 3 rows and 2 columns. So here you are going to give the number of rows and columns, not the elements. Okay, I'm just going to add this here. So rows, comma, columns, right? Now, after this, okay, so the output that you are going to get here, you can see that it is going to have 3 different rows. Yes, I just created some space so that all of you all can, clearly see it. I've just added a backslash n to create a new line. So you can see here that my output is random arrays. And then you can see that I have created an output of, 3 rows and 2 columns. Okay, this is one column and this is another column. So you can change the shape here, okay, according to your own convenience. But the interval, okay, between which the elements are going to be chosen using this random function is 0 and 1. Okay, so interval is going to be 0 comma 1. Next up, all right, so everyone, just to take you all through this, okay, np.random.rand 3 comma 2, this is going to generate you a two-dimensional array, okay, and each element in the array is a random number. You can see that they are all random numbers. Every time you're going to run it, you're going to get a new output. You can see here now the output has changed, okay, and here you can see that you are going to create this particular array which has 3 columns, 3 rows and 2 columns. Okay, so this function is often used in various applications, where random samples are needed, such as, simulations, statistical modeling, and machine learning. Next up, we have random a random RANDN function. So this particular function is used to generate an array of random numbers, okay, sampled from a standard normal distribution. So a standard normal distribution has a mean of 0 and it has a standard deviation of 1. So the result array will have the specified, shape, and each element in the array is a random value drawn from a standard normal deviation. Now, here you can see that we have created an array of the shape, which is a 2D array, 2 rows and 3 columns. And then after that, what we're going to do is we are going to pass it in our function, which is random numbers. Now, what is going to happen is that the output values, okay, it is going to have, you can see here that it is going to have positive as well as negative numbers. You can see it has both positive and negative numbers, but it is going to hold the same shape, which is 3 rows and 2 columns. So this function is commonly used in, very statistical and scientific computation where random samples, samples from normal distribution is required. This is for, you can see this was for uniform distribution. This is for normal distribution. Next up here, we have mean function, okay? It is going to compute the arithmetic mean of the given array, okay? And here we are going to find the standard deviation of an array. And here, lastly, we can find both minimum as well as maximum values. So these are all the functions that we did earlier, all right? So these are a few important functions, everyone, all right? So I'm just going to save this file and close this. And next up, so we've completed all of these different functions. Next up, we have NumPy accessing entries. So we are going to be looking at how we can access single elements, slice arrays, how you can create multi-dimensional arrays, what is Boolean indexing, and what is fancy indexing. So we're gonna go through each and every topic using our, code so that we can understand this better. So I'm going to show you a demo in the file. Let me just share my screen. Yes. So our very first topic, which is accessing single elements using square brackets. Okay, so square brackets. So here we are going to provide the index of an element you want to access. All right. So the first thing here, you can see that we have imported NumPy as NP. We have created an array which is going to be from 1 to 5. Now here you can see that we have a library which is called as NumPy, and we're going to import it as NP. And here everyone, what we're going to do is after creating this array, we're going to access the element at index 2. Please remember that the index number always starts from 0. So the numbers are going to look something like this. So this is going to be 0, 1, 2, 3, and 4. So this is how the index numbers are going to look like. Okay. So everyone, as you can see, okay, np.array, after creating this array, we have to access a specific element inside your array. So here you have to use a square bracket. So whenever you're going to use a square bracket, you can access a single element inside your NumPy array, which is ARR. So the element at index 2 is extracted and printed here using these two lines. So we're going to create a variable element. We're going to store ARR square bracket 2, and then we're going to print it. We're going to print it. So here we're going to directly give the name of the variable. So ARR2 is nothing but 3. So you can see that the element at index 2 is 3. All right. Next up, let's say you want to find elements at index 0. Okay, so the element at index 0 is nothing but 1. Let's run this and see the code. You can see here that the output is 1. All right. Next up, what we're going to do is we are going to, I'm just going to, go to our next code here, which is slicing from index 1 to 3. So everyone, what we're going to do here is we're going to import NumPy as NP, then we're going to create an array here. After we're going to create this array, we're going to slice it. So whenever you're going to slice something, you have to give the start index, okay? Start index. Then we're going to give the stop index -1. Okay. And between this, you have to give a colon. Don't forget the colon here. So the stop index is never going to be included. It's always going to be subtracted by 1, and you're going to see the output. Now here you can see what is going to happen is that there is a variable which is called a sliced array, and in that I'm going to save the name of my array and then give the slicing, which is from index number 1 to 3. So the output is going to be just index number 1 and 2, which is 1 and 2 is nothing but at index. So you can see index number 1 and 2 is nothing but 2 and 3. So your output here is 2 and 3. Next up here, we have another, another function which is multi-dimensional arrays. So everyone, until now we have seen how you can create a single array, right? But now we're going to create multi-dimensional arrays. Now, how can you do that? So for two-dimensional arrays, rows and columns, okay, indices are specified using a comma. So here, what we're going to do is we're going to import NumPy as NP, and also everyone, you don't have to do it again and again. If you do it just once, at the beginning of your program, it's enough. But here, because, we're trying to cover different concepts, I've just done it again and again. So here you can see what we have done is we have given here, we have 3 different sequences, 1 2 3 4 5 6 7 8 9, right? And then after this, what we're going to do is I want to access an element, okay, at row 1 in column 2. So what I'm going to do is I am just going to give, okay, I'm going to give the, so here everyone, please remember that you can give the name of the array, Okay, so here 2D is just for naming purpose. You can have any name. So array underscore 2 dimension, and then in the square bracket, you give rows, comma, and column. Okay, so the first row and second column. So first row and second column here, I am also going to show you this. What happens here is that our very first row, okay, and second column, the element is going to be 6. So you can see that it is at, this is our first row. Okay, this is the 0th row, first row, and this is the second row, right? Then, so I'll just name these rows. This is the 0th row. This is the first row. And then this is the second row. Next, after this, for columns, okay, 0, 1, 2. Again, column 0, 1, 2, 0, 1, 2. All right. Now, here, after giving the name of the array in the square bracket, I have given 1, comma 2. So 1 is row. Okay, so let me locate row 1. So this is my row 1. I'm here. Next, I'm going to say column 2. So now column 2, this is my column 2. So you can see that the output is going to be 6. So based on your input here, you can access a specified element using, you can even use, row and column, or you can just give the index number like we gave here, if it is a single dimensional array. Next up here, we have Boolean indexing. Now, what is Boolean indexing? Boolean indexing is used to filter elements based on conditions, right? So here what we have done, again, imported NumPy as NP, created this array, okay? Now, in this, I am going to create Boolean indexing. Basically, I'm going to add a condition. Now, how I'm going to add this condition is I'm going to create another variable, which is called as selected elements. You can give any name you want. And then after that, I'm going to specify the name of my array, which is ARR. And then in the square bracket, I'm going to give a condition. Okay. So in this condition, I'm going to select elements from the array ARR that are greater than 2. Right, so the output that you will see, so you can see the selected elements output are all going to be 3, 4, and 5, which are greater than 2. Let me change this symbol to less than, just for example's sake, and run this. And you can see here that my output, when I say less than 2, my output is 1. Let's also give equal, which is another operator. You can see here that the output is 1 and 2 because it's going to include elements less than 2 and 2. All right. So this is how you can use these operators, arithmetic operators. Okay. So this is all you have to do in the square bracket, give the name of the array and apply the condition. Next up, we have another concept which is called as fancy indexing. Now, what is fancy indexing? So fancy indexing involves passing an array of indices to access specific elements. Okay. So for example, again, we have imported NumPy. After importing NumPy, the next step that we have done here is we have, created indices. Okay. The indices here are 1, 3, and 4. Now, when I have given these indices 1, 3, and 4, what I'm going to do is I am going to basically pass them into my array, okay, which is a 1, 2, 3, 4, 5. Next, after this, I am going to print my selected elements. So here what is going to happen is that indices basically refers to the index number and it will help you access them. Now, this particular line is actually equal to, okay, how it will be equal to ARR square bracket 0, and which is equal to, so ARR 0 is nothing but index number 0, which is 1. Okay, this is equal to 1. Next up again, it is ARR square bracket 3, which is equal to, so 0, 1, 2, 3, which is 4. This is 4. And again, the last one, it is ARR 4, which is equal to the last element, which is 5. So you can see that the output is 1, 4, and 5. So this is our output, right? So this is our last concept, which is fancy indexing, everyone. Now, next up, we're going to be starting off with our next library, which is called as Pandas. So I will be continuing this in the next video. Thank you, everyone.